Yep. Hello everyone. Good morning. Are you able to hear me?
Yes.
Okay. So hope everybody practiced Spark SQL data frames sessions. So yesterday I didn't get time to upload those CSV files, and I thought of giving that use case today because today we're going to cover the most important concepts like integrating with BigQuery and all. So I thought of giving that use case today. So today we will discuss the real time project deployment of a Pyspark project, right? So if you have a Pyspark application, so how to develop it, okay, in real time, right? So in real time, it's a real time project use case, okay? So how in real time we develop PySpark applications, okay? How in real time projects we deploy PySpark applications. So this is a very important concept that we're going to see today, and then we will try to understand how we can integrate between data proc and BigQuery services, right? So let us take an example. You have developed your processing logic in PySpark, which is in data proc service, and you want to load the data to BigQuery. So how to build that integration? So what we need to do that integration? So this is one of the important thing that we do in real time projects, and we are going to discuss all those things um, today. Okay, so that is about today's session. So let us quickly understand how not only in GCP, in any uh, cloud systems, if you are using PySpark, right? So if you are using PySpark, so the development methodology is same, okay? So we have to have one IDE platform, integrated development environment. So that is that platform we need, and we need to understand the code framework, application framework, how we develop the code, what are all the things that we use, right? And then we need to build the entire code into a single package file, okay? So and then deploy that wheel file or deploy that egg file or deploy that jar file in the cluster. So this is the process that we'll follow. So let us quickly understand how actually a real-time project implementation looks like, right? So let me quickly share my screen. Are you able to see my screen?
Yes, Frank.
Yes, sir.
Yeah. Okay. So here, if you see, I have created a replication project like real time. Okay. So here I will go and explain from the beginning so that you will get complete understanding. Okay. So in PyCharm, so we need one IDE platform, right? So in PyCharm, we can develop PySpark applications. Okay, and there is one more IDE called IntelliJ. Okay, so let's quickly understand these things so that we'll don't get confused. Okay, so we need IDE platform. So in real time projects, the project's framework or the project application framework will be developed in any of the language. Okay, so it may be Java, or it may be Scala, or it may be Python. Okay, so your Spark framework supports all these languages. Be very, very clear. The underneath core behavior is same, but only the declarations and syntaxes will vary. Okay, so till now we have seen the PySpark way of doing things. Okay, so using the Python. Okay, so now for if it is Java or Scala, if it is Java or Scala, for example, in your real-time projects, they are using Java Spark, they are using Scala Spark, then the preferred IDE will be IntelliJ. or Eclipse. Okay, so if you have Java or Scala as your core programming language in your project, then the preferred IDE would be IntelliJ or Eclipse. Okay, if you have Python as your core programming language across your data science and data engineering, okay, then the preferred IDE would be PyCharm or VS Code. Okay, so these are the two IDEs that we will prefer. Okay, so now, okay, so the IDE is ready. Okay, so in real time you will get the laptops, and then you will set up your development platform. That is your first activity. Once you go into the projects, or once your projects got allocated, the first and foremost activity you'll get is the laptop collection, and then setting up your development environment. So that setting up development environment is something that you need to sit with one of your lead, or one of the developer from the team. So you need to sit with them and then install the IDEs, configure your security certificates, keys, everything with respect to that company, that organization, right? So then your IDE will be ready. Okay, and there will be a Git repository for your project. Okay, okay, Git repository for your project, where the existing team members will be maintaining a project code repository in the Git. Okay, and the first and foremost thing that you will do is pull the code base from the Git to local. Okay, because you have already set up your local development environment. So what you will do, you will just pull the code. Okay, now in the local you have IDE, in your laptop you have IDE platform ready, and everything got set up. Then what you will do, you will start developing the code into the existing framework. Okay, and then what you will do, once you completed the development, in between the development process, you can use always the Spark shell environment that we have seen, or else notebook environment that we have seen, to test your logics. Okay, to test your logics, or to understand how input and output is coming, you can pretty well go ahead and use that shell based notebooks. But actual implementation will be happening in the PyCharm, or the application level. Okay, so now your IDE platforms, you will start developing the code, and integrate it with existing framework. Okay, and then next step is testing. Okay, so do the unit testing. Okay, so run your code and check whether your data is loading properly, or your logics are working fine as expected, right? So then once you tested, right, so then you'll push it to feature branch. Okay, so that means in Git, every project follows a architecture. Like, there will be a master branch, which will be the master repository. Okay, and there will be a feature branch for each team. Okay, now usually in data engineering we'll be maintaining one feature branch, but usually we'll be having for each developer one branch, and then developer two, second branch. So what we'll do, we'll pull it from the master to this branch. So what is branch? It's a separate dedicated repository for each developer. Okay, remember, It's a dedicated repository for each developer. So now what will happen? This is a central repository for all developers. So what will happen? We pull the code from master to our local or our developer branches, and then we implement everything in that branch only. Remember, we are not allowed to directly push code to master, or we are not allowed to corrupt the master branch code. Master branch code is the clear code base which can be directly moved to production. Okay, that is after multiple rounds of testing, after multiple rounds of code review, then only you need to push the code to master branch. Be very, very clear. Okay, Git is a framework or an application that will be utilized in real time projects to maintain your code base. Okay, to maintain your code base. Okay, so your project will be having master or and developer branches. We'll pull the code base from master to developer branches first. So who will put the code base in the master? So there will be a technical lead who will be creating the project framework template, and then he will be pushing that to the master branch. Once after his testing, he'll be pushing that to the master branch. Then all the developers will pull that code base into the developer branches, and then they will start developing the things. Okay, once the day development got completed, day testing got completed, then they will push that code to the feature branch. Okay, they will push that code to the feature branch. Okay, so this is how they will try to do it. And once you have the feature branch, once you have the pushed the code to feature branch, then what they need to do? They need to do one more task called raising the pull request. Okay, we call it as a PR, right? So pull request. So once they push the code after their testing, once they push the code to feature branch, then they will raise the pull request. This pull request is for merging the feature branch code to master branch. Okay, and this will go for the code review to the technical lead. Be very, very clear. This step will go to the code review by your technical lead. Now once the code review happens, then your technical lead will approve that pull request, so that whatever the changes that you have done will be merged with the master branch. Okay, this is the process that we will follow. Okay, now again you can ask, so how actually this project will be driven, right? So we all will follow a methodology in real-time implementations called Agile. Okay, so this is the software methodology that we will follow. Okay, and in Agile meaning it's a process to follow when we are developing applications or when we are working in the software industry. There should be a methodology or there should be a process that needs to be followed by all the developers in the organization, right? So that process, we have couple of known methodologies in the software industry. One is the waterfall methodology and agile methodology. Okay, now what is waterfall methodology? So when BA comes with the requirements, okay, when BA comes with the requirements, so SA, solution architect, will convert it to solution, right? I mean the architecture, the design, everything he will do. And then uh, dev team will implement. Okay. Now BA will get the requirements, SA will convert to solution, and dev team will implement. Okay. So in waterfall methodology, we'll be having phases. Phase 1. Okay, I got 10 requirements. Okay. Now what will happen? SA will freeze. Okay, freeze the requirements, and dev team will implement. Okay, and deploy deploy the phase 1 code in the production. Okay. So starting from the requirements till the production deployment, there will be one timeline. Remember, there will be only one timeline. Let us take an example: 6 months. Your SA will commit 6 months. Okay, see, we'll take these 10 requirements, and then we will take 6 months, and we will implement and we'll deploy your code in the production for the phase 1. And again, if next requirements came, extra requirements, so they will keep them for phase 2. Okay, another 5 requirements. Okay, so that is what waterfall methodology. But in the agile, you will be having sprints. Okay, and stories, tasks. Okay, so this everything we will be using a tool called Zira. Okay, the work Zira is a tool that we'll use to track our day-to-day work. Okay, now you developed 5 different functionalities, and you need to you pushed it and you tested it. And how you will know that you need to do that work? First of all, right? So your lead will assign that task to you. Hey Venkat, go and develop this particular Pyspark functionality in the existing data framework. So that's how you will get the task, right? So that tasks we will maintain in Zira. Okay, so now in Zira, uh, every sprint, so that means sprint means, let us say we will maintain 2 weeks. Okay, the 2 weeks is the normal sprint that we'll follow. Okay, for some projects we'll be having 3 weeks also. Okay, now your lead, before starting this sprint means it's a time frame in Agile. Okay, so for that sprint, what are all the tasks that needs to be completed, right? So that a list he will take from the BA, and then he will assign the stories and tasks to you. Okay, under each story you will be having multiple tasks. Okay, so let us take an example. There is a logistic group and logistic data ingestion. Okay, under logistic data ingestion story, you have 10 different tasks for 10 different tables. Okay, now each task will be performed by each developer parallelly, so that the work can be done faster, right? So every sprint, before the sprint, he will sit with the strategy leaders or I4 analysts or data scientists. Then he will gather all the requirements that are there in that sprint. Then for that sprint, he will assign all the tasks to developers. And at the end of the sprint, we have, I mean, daily we'll be having stand-ups in Agile. In Waterfall, it's not mandatory, but in Agile, we'll be having daily stand-ups. And in that stand-ups, we have to update the progress on the tasks. And then for every sprint, we have to complete all the tasks that has been assigned. and push the code to master. Okay, and deploy it if possible, but majority of the projects will deploy once everything got completed in data engineering. But if it is in application development, it's a sprint wise deployment you will see. Okay, it's a if it is a web application development, you will see sprint wise deployment. But in data engineering, we don't see sprint wise deployment, we will see project wise deployment. Okay, though we follow the sprint based structure, we push the code for every sprint, we push the code to master. Okay, and then at the end we will pull the code from the master and we will deploy it in the production. That's how it is going to happen. Okay, guys, any questions in this project's implementation? Are we clear?
Yes, sir.
Anusha,
Yes, Venki.
are we clear? Any questions or queries? Okay, fine. So now let us understand how actually a real-time project, Pyspark project implementation will happen, right? So here, if you see, you'll be creating a project. Once you go here, you'll be creating a new project, and then in your local, right? So these all things will be done by the team lead. If you are creating a project, you can also do that. I mean, if you get an opportunity to create a project, you can pretty well do this. Okay, so now here, if you see GDW data pipeline, so this is my project name, and I created this project, and then inside the project, I have created the config package and logs package, and then SRC module, table loader module, utils module. So everything I have created. Okay, so and then I have one main file. Okay, and I have one setup file. Okay, so this setup file is the build file. Be very very clear. So this setup file we'll use for building. So build means you will write lot many, I mean, you will write more. Most of the times you will be utilizing hoops in the projects, and you will be writing lot many classes, lot many methods in lot many Python files. Okay, but it is not possible to deploy all the Python files, right? So you need to generate a single Python file or a single build file or package file out of your entire PySpark project, right? So that is where your build will happen. It will generate a single file to deploy. Okay, so now let us understand quickly. So here I have main file, and these are all the segregation, guys. You cannot, I mean, if anybody comes and see, it looks good, the project looks meaningful and understanding. So that's why we always segregate the application into different directories. Okay, so the main application code base will be in SRC directory, and the log related things will be in logs directory, and configurations, any constants or configurations or anything, right? So those will be in config directory, and any functions, right? So any typical functions, let's say getting the current date, or getting current date minus 5 days, or any date utils, or any static functions, we will, I mean, that can be utilized in a lot of classes, right? So those static functions will keep in utils directory, right? So and then data models, you can data models directory you can create. So table loaders directory you can create. So I'm just giving a brief structure here, but it may vary with respect to the project. But this is a basic version. You can pretty well follow this in your projects. Okay, so then what we'll do, we'll be having a main file __main___ dot py. Okay, this is the main file that we maintain, where actually our program will start, right? Which is the entry point for our program, right? So now if you understand this here, I am importing my processor or my application class into this main class, right? See here, from src dot gdw data loader import gdw data loader application. So what does it mean? Now let us understand that. So in src is a python module. The reason being, if you have underscore underscore init underscore underscore dot py, if you have this file in any of your directories, project directories, then that is one module. Your python will treat it as a module, not a directory. Remember, your python will treat it as a module, not a directory. So here if you see, your init.py refers your src directory is a module, okay, python module. So now in that src, I have a file called gdw data loader. This is my application file, okay. Now this is my python file, and then in this python file I have a class called gdw data loader application. So that is what I am calling here. From src.gdw data loader import gdw data loader application. Okay, so this class I'm calling in my main function because this is my core application class. Okay, starting application class. Now in the main, okay, our program started, and then I am expecting two input arguments for my application. When I am running my application, I am expecting two input arguments. Okay, so these two, how to get the input arguments from the outside to your application? We will use sys.args v of 1 args v of 2. So this is the way that we will get the outside parameters to the code. Okay, now fine, we got raw zone path, I mean the input file path, and we got the target table name that needs to be loaded, right? Then what we are doing, so we are trying to prepare a object for our gdw data loader application. Okay, see here, we are creating the object. Okay, we are creating the object. Now for my class, this gdw data loader application class, what is the input that needs to be passed? So in the constructor, in the underscore underscore init function, so what we have defined, so at this moment do not get into a confusion that what is a class, what is a object. No, right? So we have discussed everything in our previous python sessions. If you are not clear, please go back and revise our sessions. Okay, so we are creating a object for that class. We just imported the class, and then in the line number 1 we imported the class. In line number 12 we are creating the object for it. Okay, so once we create the object, it will expect two inputs because I have declared two inputs in my constructor of this class. Okay, so once I have the object, then I have a method called run in my application class. So that is what I'm triggering. Okay, then what will happen? So it will start, it will go, and it will run that method. So what is there in this class now? I have a constructor. See here, def underscore underscore init underscore underscore, and then I have input file path. Okay, and then target table. These are the two inputs that I am getting from the outside of the application at the time of deployment. Okay, now I have got two inputs, and as it is a Pyspark application, I have to create my Spark session and then Spark context, right? So I have to create my Spark session and Spark context. So for that, I'm actually maintaining the Spark session and Spark context in a different class. The reason being, You have to maintain one single Spark session for your application. Okay. So if you want to maintain one single Spark session, then what will happen? So you need to call that Spark session from all your classes, right? So that's why you have to make it available to all the classes. So that is why we are maintaining that in the config class. Okay, so in the config directory, if you see, okay, I am importing a class called config from config dot config. Okay, that's your Python file name. Inside the Python file, you have config class. Okay, inside the Python file name, you have the config class. Okay, now you already imported this config class to this main application file. Okay, now in this config class, what is there? See here, I am preparing a configuration for my Spark. Okay, I'm preparing driver cores. How many cores that you need for your driver? Okay, two. Driver memory, how much memory you need to allocate for your master service driver, right? 5 GB. And dynamic allocation enabled, dynamic min executors, dynamic max executors. So this concept, right? You can actually scale your Pyspark application according to this configuration. Be very, very clear. This configuration will help you to scale your Pyspark application, meaning it will start with two executors, or else minimum executors are one in my case. So your application will start with one executor, and it will identify the load, and depending on the load it will scale the executors. Okay, depending on the load it will scale the executors till the max executors got reached. That concept we'll call it as dynamic resource allocation in Spark. Okay, dynamic resource allocation in Spark, that can be achieved by this configurations. So in my case, my application is scaled from one executor to two executors depending on the load. Okay, now, this is what you will see in the real-time projects also. And statically, we also can define spark dot executor dot instances. So that is the parameter that defines the static executor. Okay, so that means let us say here spark dot executor dot instances, right? So this property will be, let us say, 10 executors I have given. It will launch initially. Initial stages itself. It will launch 10 executors. Okay. So whatever happens, it will run in the 10 executors only. From the starting to ending, you will be having 10 static executors allocated. Okay. But your dynamic allocation will save the resources according to your Spark application transformations. Okay, so that is why we majority of the times we go for dynamic resource allocation. Okay, fine. So next property is the executor memory. Okay, so how much executor memory I want to give? Okay, for each executor I want to give 5 GB RAM. Okay, and then the master, which is actually the resource manager that we are using, right? So which is yarn. Okay, so yarn is our resource manager. And then application name, what is your job name, right? So you can say job underscore GW data loader. And then shuffle partitions we have discussed yesterday, right? So spark.sql.shuffle.partitions, right? And then temporary GCS bucket. So this is my temporary GCS bucket. And then these are all BigQuery related configurations: materialization dataset, views enable, and then materialization expiration time. So Spark uses some temporary BigQuery space when you are writing your Spark data frames to BigQuery tables. It will use some temporary space. That space configurations are these. Okay. you will get them when you are in BigQuery integration. But for now, in this config class, I have declared my configurations first. Okay, and then what I'm doing, I'm trying to initialize my Spark with all the configurations that I have declared here. Okay, see here, this is how you will create initialize a Spark method, and you need to create your configuration object first, and then for every element that that is there in the dictionary, okay, your config variable is a dictionary type, right? All the configurations you kept at one place, and then you are iterating that dictionary, and you are setting that to the existing conf object, right? Conf.set, and you are setting it. Once you set all the configurations to the conf object, then you will create the Spark session, okay, with all the configurations. Okay, then you will create the Spark context if it is needed, because if you are working with RDDs, you need Spark context. So that's why. So we always return both from this initialize Spark method. So okay, so I'm returning Spark and SC. Okay, now coming back to our application again. So that is where I got my Spark session and Spark context from this config class. Okay, now I'm declaring few run date. So what is the current date that I'm running, right? So here if you see, get current date is a function that I'm calling, and which is there in the utils. Okay, so which is there in the utils. This is also a Python module, and you have utils class, utils Python file here, and in here you have a function called get current date. Okay, so this is just to have a proper code base, guys. You can ask a question, can't we write it in a single Python file? Yes, always, but it will become very hard for you at the time of deployment, and it will become very hard for the people uh, who are joining to understand your code base. Okay, so that is why we'll always follow OOPS based framework based model in real time projects. Okay, fine, just give me a minute, guys. Okay, so fine. So here, if you see, this is how I maintained my utils class. Okay, and I have got the get current date and then input file. Anyway, I'm getting the input path and the table name, target table name, and I need to load the data first to my stage table and then to the target table. So I have created my stage table variable with stage underscore, and then I'm taking some hard coded project names and BigQuery datasets, right? And the target table name. Okay, so in real time, you will maintain a logger, guys. So you don't use print statements. Be very clear. So you use logger statements instead of print statements. Okay, and the reason being, so you will be writing these logs to you can write these logs to some other files or some other place to review later. So that is the reason you will always use logger in real time projects. Okay, so that's why I'm just initiating the logger, and then here I have the run method. Okay, now here if you see, if self dot table name equals to sales data, if the table name is this, then go and execute this logic. You can control your flow depending on your input variable. Okay, because you don't maintain one separate Python files to tables, right? So here in the single framework itself, here if you see, I have a table there, table loader, and for sales data table, I have a logic here in this class. Okay, similarly for retail data, I'll create one more functionality. So for other table, I'll create one more functionality. So it may be different. So for example, in yesterday's use case, we have created three tables, right? Product performance report, and then a regional performance report, and then seasonal trends report. Okay, so depending on that naming conventions, also they will create the classes here. Okay, so but for us it's a plain table to table load, so that's why I actually created the sales data loader. Okay, so now if you see here, just one minute. Okay, so now okay, so if my table is sales data, what I need to do, so I need to, one second, so I will just remove all these configurations. Okay, I need to go and create the object for my sales data loader class. Okay, I imported that class into this. So here if you see table loader dot sales data loader, import sales data loader. Okay, so once I have created the object with all the required inputs to that class, then what I'm doing, I'm just triggering the run for that table. Okay, so this way you can actually execute your entire framework for a single table also. Depending on your input, it will run. Okay, depending on your input, it will run. Okay, so and then the try catch exception handling, so this is very important, guys, in real time. Exception handling, so this try and then except, right? So in Python, so as and when a successful run has happened, so what you will do, you will be updating your control tables. Update control table. Okay, so you will maintain control table for entire your project, where actually you'll be tracking all the jobs related statuses. Okay, so once every job got completed, we'll go and update the status there. Okay, and if it got failed, then also we need to update the control table with proper error message, right? So that is why we'll always write some logic in the except block also. Okay, so now if you see here, if the table name is this, then go and execute this particular logic. So what is there in this logic? So now here I'm just forming the input path. Okay, so for that current date or run date, I'm just forming the path, and in that path I have the CSV files. Okay, and I'm just writing my Spark code here. Okay, see here where we are writing the functionality. I mean the framework you need to understand first, then the functionality. Okay, so till now we have seen how to implement Spark code, but till today we have learned how to develop a application, right? So this is important, guys. So I mean people may feel that okay, so if I have written a simple Pyspark code, then I'm very good. No, you should develop frameworks, you should develop applications, then only you are a good developer. Be very very clear. If you're writing a Python scripts, then you are a script then you are a then you don't become a developer. Okay, you will just be as a script maker, that's it. Okay, so there is a lot of difference between scripts and frameworks. Okay, so frameworks are flexible, easy to deploy, easy to automate, right? And frameworks will give you the functional flexibility. You can tweak the, you can parameterize everything, and you can pass, and you can make the framework work according to your logic. But script is a standard way of doing things, and you cannot make it more flexible. So do not develop scripts. So whatever the Python file that we deployed initially, right? So that is a script. So we developed a Python file. See here, word count.py. So this is a script based deployment. Okay, and this the now we are seeing the framework based deployment. So this will be for a project, that will be for a use case. Okay, So in a project you will be having n number of use cases. So you should have one framework that needs to be maintained across all the logics. Okay, fine. So here what I'm doing, I'm just reading my CSV file into a data frame, and then I'm forming my BigQuery table. Here comes the BigQuery integration, right? So I'm forming my BigQuery table here. Okay, depending on the inputs that I got, I'm getting stage table also. So I have actually formed my BigQuery table, and then I'm writing it. Okay, and then I'm writing it. Just 1 minute, guys. I need to join one meeting. I'll come back. 1 minute. Okay, fine. So here, what I'm trying to do, so I'm trying to integrate my Spark program with BigQuery. Okay, so whatever the data frame that I got, I'm trying to write it into BigQuery. See here how I'm actually writing Spark data frame dot write dot format. So simply like CSVs or packets. So we are just writing it. So write dot format BigQuery dot mode overwrite. So every time it will overwrite the table, and in the option I'm just passing the table name. Okay, and then I'm using the save. So this will be your action, guys. This will be your action. Okay, fine. So this is what my application, guys. So finally, what I'm trying to do, I'm trying to read data from a GCS directory, or else wherever the input path that I'm going to provide to my application, it will read it from there, and it will create a data frame, and then it will write it to BigQuery table. So that is the application that we have developed, and with all the modularized code base. Okay, fine. So let us quickly see this setup.py file. So this is the build file, right? So this is where actually you will maintain your application name, and then version, and then description of your application, and then who have written it, and then what is the main class. Okay, and then packages, what packages you have. So I have the config package, and then table loader, src, logs, utils, right? So these are all the things that you will give here. Okay, so that it will combine all these packages, and it will create a single file for you to deploy. Okay, so now how to build this entire code base. Okay, so I have written the code, everything is ready. Then how to build my code and develop a single file out of it, right? So that is where you use this command, right? So when you build any Python project, you will get a wheel file. Remember, wheel file. It's a build file, we'll call it as. Okay. This wheel file you will deploy. Okay. And that will be one for entire project. Okay. So now this is the command that we will use: Python space setup.py. So you are already in this directory. Okay. GDW data pipeline. This is your directory. In this directory, you can trigger this command. Okay, Python setup.py, and then sdist bdist underscore wheel. That means build distributed wheel. That is what the command meaning. So when you hit enter, it will start building your entire code into single file called wheel file. See here, it will generate that wheel file under dist directory. Okay, dist directory. So this wheel file, if you see GW data loader version, and then it's a Python 3, right? And you can name it further also, but I didn't do it, so that's why it was coming as none and any. So you can actually use this WHL file. If you see the extension, it's a wheel file. So this file holds entire code base of your project. Okay, fine. So now we developed the code base for a project and then we build it into a single file. Okay. Now what we need to do, our next step is to deploy it in the cluster, right? So how we will deploy it? So again, we'll go to GCP notebooks, and I have my cluster ready, which is cluster dev. Okay, so and I'll go to my Vertex AI notebook. So once you go into the Vertex AI notebook, you will be submitting this wheel file to the cluster. Okay, so this is my terminal, and what I'm trying to do, I'm trying to upload my a wheel file into my directory. So I already have. I'll just overwrite it. Okay, so I will simply use my deployment command now. Okay, so what is my deployment command? So here, if you see, this is my deployment command. So understand it. Gcloud dataproc jobs submit. Okay, Pyspark, and your main file path where it is. Okay, and you need to pass that main file underscore underscore main underscore underscore py file. So the file that you have here, right, which is the entry point for your application, right? So that file you need to pass after Pyspark, and then hyphen hyphen cluster, your cluster name, and the region, your region of your cluster, and hyphen hyphen py hyphen files. This is the parameter that you will use along with the submit command to pass your wheel file. Okay, to pass your wheel file. And then after that, hyphen hyphen jars is another parameter that we'll use to actually pass the supporting jars, right? So if your application needs any external jars, or if any a third party dependency jars, you can pass them from this jars parameter. Okay, see here, my application needs to write the data to BigQuery from the Python PySpark. So I need a Spark BigQuery dependency jar. So that is where I'm just passing my jar along with the hyphen hyphen jars. Okay, and then at the end, if you see hyphen hyphen space, you need to pass your arguments to your wheel file. Okay, so in the beginning, in the main file, we know our application is taking two input arguments, right? Sys.args v of 1, sys.args v of 2. So those arguments you need to pass it here. Okay. The raw zone path and the table that I want to load is sales data. Okay. So if I simply trigger this in my notebook, because my main file is also there in this directory, in the same path, and then the wheel file also there in the same path. In real time, what we do, we put them in the git repository. Okay, and then we will pull it from the git repository sometimes, and in some projects we'll place them in the GCS bucket and we'll pass the GCS paths here. Okay, fine. So that is about this command, and I'm just hitting the trigger. So it will go and submit to the cluster. And we can go and quickly look at the yarn portal. See here, our job GW data loader got submitted and it is running, right? Containers running max executor. So you have given two, so it created two executors, and then it will go here and it got completed, right? So you can pretty well see the logs from the starting. So process started and your input arguments are this, and you're loading the sales data table and then entered into the table block. These are all the print statements that I have kept. And here, if you see the logger message, this is how your print statement is different from your logger message, right? See here, our application got failed. Application failed at sales data table load. Error message is path does not exist. GW dev training default raw zone sales data 24,830. So this path does not exist is what it is saying. Okay. So we need to correct it. Now, if you just understand your print statements, guys, print statement meaning it will come like this. But your logger, how it is coming, see here, your class name, your timestamp, and whether it's a error or information, so it will come like this. Your logger message will come like this. Okay, now our job got failed. Now we need to fix it, right? So how to fix it? Because it is saying your GCS path does not exist. The reason is you are forming the table name with the current date, right? So, or you are reading the data with the current date path, right? So that is where it is giving the error. So because I have the file for yesterday's date, not for today's date. So what I will do, I will simply go here, and then I will update my run date. That's it. So I will say like how it is giving 2024 8/29 I need to give. That's it. Okay. So now my run date will be updated with this previous date, so that it will find the data. So now what I need to do, I need to again build my file. Okay, so whatever the change that you need to do, you need to save it and then build it and then deploy. This process is same, guys. Okay, so this process is same. So I'm just uploading, overwriting, and then deploying. Guys, any questions, guys? Please ask. Don't be silent. I'm confused whether you are getting it or not. Are we able to understand?
Yes, Venki.
Yes, Venkat.
Okay, fine. So that is about the deployment of application, guys. See here, my data frame got presented on the console, right? And it is now writing data to BigQuery table. See here, it started printed all the BigQuery load log, and write also completed. Okay, so we can quickly go and check our default data set. Okay, so I have given data set as default data set, and I have this. So stage underscore sales underscore data, and this is my data, right? Okay, so this is how you will deploy a real-time project use case or project application, guys. Okay, now going back to our yesterday's use case. So now you can go and implement your projects in this way. I will upload this project into Git repository. Okay, I will upload this project into the Git repository. Let me quickly do that
Can
activity.
you, Venki, can you click on this init py? So what it actually contains? So you said like if we
Nothing.
have
It's
it
an empty file. That's it.
empty file that actually differs module like that, right?
Yeah, directory and the module.
Okay,
So, for example, in the build file, your setup should detect it as a package, right? So, if it wants to detect it as a package, that means you are giving config. If it is a directory, it won't be able to detect. Your packages won't be able to detect, and it won't build it. So, if you keep init file in it, then it will detect it as a package or a module, Python module.
okay.
Yeah.
So I have observed one thing that until now we have written our Pyspark in cluster only, right? So
Yes.
in
Correct.
Pyspark, so
Correct.
the extension for that is like something different, not py. IB something
Yeah,
some other.
that is the notebook. So
Okay,
IPY and B, that's a Jupyter Notebook extension. Okay, you cannot deploy notebooks. Actually, notebooks are
okay,
a shell-based environment. If you want to execute a step-by-step, or if you want to, usually we have PySpark shell, right? So that's
okay,
the enhanced version of your PySpark shell, wherein that UI and cell by cell you can execute and run test. For that only we'll use that notebooks. That notebooks are Jupyter notebooks, and those are having a different extension called IPY and B.
okay, okay.
Those are for our
For this,
testing.
do we need to add any extension for implementing the Pyspark?
No, no. Everything is PyFile only.
Okay,
Everything that you are the same thing that you are seeing here in the project. Everything is .py only. That's why it is PySpark. So it is completely coupled with Python. That IPYNB is your notebook extension. You have a Jupyter notebook. You click on Jupyter Lab, right? So that
okay,
Jupyter Lab is a notebook user interface tool wherein you can interact with PySpark with notebooks. That's it. Okay, but in real time you
okay,
don't deploy that application, deploy that notebooks. You will uh, you will try to use that notebooks for your testing. Okay,
okay. Got you.
so fine, so let me quickly upload this directory into the git. So I will try to create add files, upload files, it is there, but okay, no problem. So what I will do, I will try to create a directory here. I don't know whether I can add a directory. No, this is going on a file level. Okay, I'll find out a way to add this entire directory to your. Okay, here I have the projects. Okay, just trying to create a new project here. Okay, I'll find out a way and I will try to upload this to the Git repository, guys. Okay, the entire things that we have done, and then I will also give you the build command and the deployment command also. I will place it in a note text file. Okay, so I uploaded the use case and the sample files in the Git repository. Okay, I want you to create the PySpark project tomorrow, and then deploy and populate these three tables in the BigQuery according to the use case. Okay, we have these three tables, right? Product performance report, regional performance report, sales trends report. So you need to develop the project and write the logic, use my framework, okay, whatever the template that I have written, use that, and then try to implement your logic, and then deploy it. Okay, so I want to see these three tables from you by tomorrow. Okay, so that's all I have. So I will upload
Uh,
this. Yeah, any questions? Any questions? Okay, fine. So I will try to upload this and put it in the Git repository. Okay. That's all I.
Venki,
Yeah.
one thing. So the current project motto is just loading the data into BigQuery table by reading the data from CSV,
Yes, correct.
right?
But the use case is different. According to the use case, you need to develop the logic.
Okay, no, no, just whatever you showed, right? So
Yes.
that's what I'm talking about. So
Okay.
the motto of the project is the what I said.
Yes. It's just
Okay,
reading a CSV file from GCS
okay,
and then writing it into BigQuery. That's it.
okay. So in the same fashion, we have to
Yeah.
do for other and then load the data into BigQuery tables. From there, we have to use data proc and manipulate the data and
No, 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 no. You need to read this. You need to place the CSV files in the GCS.
okay,
You need to read them from the GCS, apply the processing logics in data proc Pyspark application, write the results into
okay,
BigQuery table.
okay, okay. Got you.
Okay. So that means in BigQuery, you will see three tables: one product underscore performance underscore report, that's one table; regional underscore performance underscore report, that is another table; seasonal underscore trends underscore report, that is another table. Okay.
Okay, yeah.
Yeah. Fine. So that's all I have for today, guys. I'll upload this framework template into the Git repository along with the build command and deployment command. And I already uploaded the CSV files and the use case document in the Git repository. So please go ahead and try to implement it. It's gonna give you a good exposure, and going forward in real time projects, you will be developing these kind of applications only. Okay. That's all I have for today. Thank you so much for joining once again on tomorrow. Yeah.
Yeah, thanks.
Thanks, Venki.